So I got two arrangements. Which one is the higher potential energy arrangement? So this is actually the bottom one. Why is that? It's because if I was to release this and this, they would move together and meet maybe around here. If I was to release these two, basically there's just a greater space for them to accelerate over, hence a greater kinetic energy, and hence a greater electric potential energy in the original arrangement. What about this one? This one, the greater electric potential energy arrangement is actually when the two charges are closer. So this is the key difference between gravity and the electric force. Gravity is always attractive. So when the masses are farther, that's a higher energy arrangement. But over here, higher energy arrangement was when they were farther because the charges were opposite. So they're also going to attract, similar to gravity. But here, the masses are going to repel. So where are you going to get a greater distance that the force can act over? It's when they start closer. Another way to think about it is by the time that these two charges get this far apart, they'll already have achieved some amount of kinetic energy. They'll already have reached a certain speed. So at that point, they have a kind of a head start. Okay. What about this arrangement? Which test charge? This one or this one has the higher potential energy? It is the closer one, similar to the previous example. What about this one? It is still the positive test charge. Just elaborate on this one. A negative test charge out here would move towards the source charge, but it only has this distance right here to accelerate over. Whereas this positive test charge, it has an infinite distance to accelerate over. So that's why this is the higher potential energy arrangement. What about this one? This one, the farther it is, the more distance it has to accelerate. In both cases, they're both going to move closer to it. So this is the higher energy arrangement. What about this one? It's kind of flipped. It's the farther one that has, again, more distance to accelerate over because they are being attracted. What about this one? It's kind of reversed or inverted the previous example that it did. This one has basically an infinite distance to accelerate over. This one has only this short amount of distance to accelerate over. Take a second. It's the farther one. Oh, no, it's the closer one. Whoops. Because, yeah, they're being repelled. So this one has the greater infinite distance to accelerate over. And what about this one? Kind of like a real world example. A balloon, and now here the pieces of paper were far, and now they're kind of attached. So the higher energy arrangement is actually position A. You can think of it as in position B, that electric potential energy has become a gravitational potential energy. Or you can think of it as like the paper moved, so it gained kinetic energy and then it collided over here. And so, like, where did that kinetic energy come from? It came from the original electric potential energy. This one's kind of a review of of just Coulomb force, kind of a vector question. So take a second to read it over. Okay, so the net force on this charge over here, there are three other forces acting on it. So this is the charge Q. Then the bottom plus 2Q is exerting a force upwards. The 2Q over here is exerting a force to the left, basically equal, but to the left. And now this force, the force from this negative Q charge on this guy is down and to the right. It is a little bit farther, so that's why it's a little bit smaller. And so if you were to add these three things together, you would get that. Okay. And last but not least, wait for it. Oh, so yeah, it's A. And take a minute to answer this question. It's not talking about force, it's talking about the electric field. Okay, so this one's similar to the last one in that you're adding vectors. Key idea though, this is a location. There is no charge here, but we can think about the electric field from this one, and this one, and think about in what direction what's the resultant. So the negative is, sorry, I'll do it over here. Negative in the bottom right corner, a positive test charge would be attracted to it. A positive test charge would be attracted to the one in the top left corner as well, and it would be repelled by the one down here, a positive test charge. Like charges repel, so then the overall net electric field is, again, A. That concludes the electric potential energy video. Try the practice. Hope that was helpful.